Hi everyone, welcome to the final video in our series. We've, in the previous two videos, looked at two methods for solving simultaneous equations, elimination and substitution. Now we're going to put those two methods together. You can choose which one you prefer, and we're going to use this to approach some harder worded questions in which we need to do a little bit more problem solving and breaking down the information in these questions. Now, we have two questions that we're going to work through today, and let's just get straight into it. So, as we read with all worded questions as we've been doing, we want to underline or highlight the most important bits. Now, here we have in this question, the sum of the ages of two children is 17. Okay, that seems pretty important. So we have the sum of the ages of two children is 17. And the difference of their ages is 5. If Sue is the older sister to Ben, determine their ages. Now, let's think about what we've just read and try to come up with, because we want to make this into some simultaneous equations. So we want to make an equation out of these bits of information. So first of all, let's give Sue and Ben some pronumerals, some algebraic letters to represent their ages. So we're going to say here, so let Ben's age be B, and we're going to let Sue's age be S. Okay, so let's break down this information. The sum of the sum of the ages of the two children is 17. So that means if we added Ben's age with Sue's age, the answer, the total, would be 17. So let's write that out. So we have here B plus S equals to 17. And that we can call our equation 1. Okay, and here we have, so Sue is the older sister. So that actually is quite important. If she's the older sister, it means her age is going to be the bigger one. So we have here, the difference of their ages is 5. Now, difference means some kind of subtracting or minusing. So Sue is the older sibling, so her age minus Ben's age is going to be 5. So we can write S minus B equals to 5. Okay, now let me actually rearrange some of these because I've got Sue on the left, Ben on the right down here. So I'll do the same up the top because when we add, the order doesn't matter. Okay, so now we've used this information, we've broken it down and made it into a simultaneous equation. That's the hardest bit. We want to look for clues in the question as to what kind of operations we're doing. So we have the sum of the ages, that means plussing. So we can make an equation with the two ages adding to give me 17. And the difference means a subtraction. So the older sibling's age minus the younger sibling's age is going to give me 5. And now we have two simultaneous equations. Now, you guys can solve this however you'd like, but I'm going to solve this, if you want to pause the video and have a go, but I'm going to solve this using elimination. So solve via elimination. Now, why have I chosen that? Because I have some pretty easy coefficients that I'm working with here. I have 1, 1, 1, and 1. So what I'm going to do is I'm going to add the two equations together. Adding them together, that's going to get rid of my b's here, because I'm going to be doing 1 plus minus 1. 1b plus minus 1b. So that's going to give me 0. So here I'm going to do equation 1 plus equation 2. You can minus them as well to get rid of the s also. As we looked at in the last video, there's a bunch of ways you can go about doing these. So adding these together, I'm going to add the two ages here. I'm going to add this here, and I'm going to add these here. So 1s plus 1s gives me 2s, and 1b plus minus b gives me 0. And on the right hand side, I have 17 plus 5, which gives me 23. Oh, no it doesn't. It gives me 22. Okay, so now I have here 2s equals to 22, and from here I can just divide both sides by 2 to give me the value of s. So here s equals to 22 divided by 2 gives me 11. So what is this s here again? Well, s is Sue's age from this line here. And now that we have s, we can substitute it into either one of these equations. Now I'm going to substitute it into the first one. So what we're going to do here is we're going to sub s equals 11 into equation 1. Okay. Now what will I get there? Finally, I'm going to get 11 plus Ben's age gives me 17. And it becomes a pretty straightforward equation to solve. So I get left with B equals to 17 minus 11 gives me 6. So we're breaking down the wording into two simultaneous equations and then just doing everything we've been doing so far. It's going to become easier to work through. So that's the first question. Let's look at one more here to end our topic. We have, at a store, a shake is $2 more than a juice. Okay, that seems like a good piece of information. A shake is $2 more than a juice. Now let's keep reading. If 3 shakes and 5 juices cost $30, determine their individual prices. So I have 3 shakes as well as 5 juices. They cost $30 in total. So I'm going to first just define my variables, define my unknowns here. So I'm going to let my shake be S, the pronumeral S, and then let my juice be J. Okay, so now is the tricky bit. We want to make these words into 2 separate equations. So let's look at this first bit of information. A shake is $2 more than a juice. So my shake here, S, is going to equal the price of a juice plus another $2. That's what we're being told here. A shake is $2 more. So whatever the juice costs, that price, we're just going to add $2 to it. So we can write the shake as the juice plus 2. And that is our first equation. And our second equation, 3 shakes and 5 juices cost $30. So this is taking us back to algebra and how we could break down these different bits of information. So I have 3 shakes, so 3 lots of the price of 1 shake. So 1 shake is just S, so 3 shakes is going to be 3 lots of S. So 3 shakes plus 5 juices equals to $30. And now we have our two simultaneous equations. So, from the previous video, I talked a lot at the end about you have both of these methods now. It is up to you to choose which one you'd prefer. And sometimes for certain questions, depending on how they're laid out, you may want to use substitution, you may want to use elimination. It's good that you have your head around both, so then that way you can just apply the relevant process to whatever the question gives you. Now, in the previous question, for example, we could see that in this case, because of the signs and because all of the pronumerals, the coefficients of the pronumerals, all these ones, were exactly the same. So elimination was a lot easier here. But now for this one, let's have a look. We have an expression for S in terms of J. So therefore, we can put this entire expression here for S into here. So in this case, the S's are the same. So the substitution will work. We can put the J plus 2 in place of the other X because I'm told that these are equal. That's what my sign here tells me. These are equal and these two are the same. So I can substitute my J plus 2 using substitution now. Via substitution. I'm going to solve this in the second method that we talked about. I wanted to use both of the elimination and substitution methods for each question here. Okay, so now I can put J plus 2 in place of the S. So I'm going to get 3, and instead of multiplying by S, I'm multiplying by J plus 2. And I'm adding 5J to that, and that equals to 30. So now I have an equation with the same pronumeral. So I am actually able to solve this now. So when we solve these, we want to first expand the brackets here. And I have another 5J that's getting added on top of that. So 3 times J gives me 3J. 3 times 2 gives me positive 6. And to that, I'm adding 5J. And this equals to 30. And now I can see I have two like terms here. So I want to add these two together. 3J plus 5J gives me 8J. Plus 6. There's nothing more we can do with this 6 on the left-hand side, so we're just adding it here. Equals to 30 on the other side. And now it just becomes a matter of solving the equation. So I'm going to subtract 6 from both sides here to get me 8J on its own. That gives me 24. And dividing both sides by 8, that gives me my value of J. So that's 24 divided by 8. So that's going to be 3 here. Okay, so let's just refresh our memories. What does J mean? Well, we set J to be the price of my juice. So the price here, my J, is actually going to be $3. Okay, and now we want to use this to find the price of my shake. Now, which of these equations do you think is going to be easier to substitute the price of juice into? Well, I don't know about you, but this one down here looks very annoying to do, and it looks like we're going to have a lot of steps. So equation 1 will be a lot easier because we can just substitute the J straight in. So my price of my shake, so actually let's write it down. I'm going to sub J equals 3 into equation 1. That's the easier one because I know my shake is always going to be $2 more than my juice. So I'm using that equation here. So my shake equals my juice plus 2. And I'm substituting in J equals 3. So that goes into here. So my shake is 3 plus 2. That gives me $5. So that's how we can use our simultaneous equations, and the method that we choose, elimination or substitution, just depends on the question. For some questions it may be easier to eliminate, for some it may be easier to substitute, or you may just have your favorite preference which you go to no matter what. That is an option too. But that brings us to the end of our topic. Thank you so much for joining me, and I'll see you in the next one.